So hello students, this is Mrs. Raksha Shirodkar from State Vidya Mandir English High School and Junior College of Commerce and Science. We'll see with the same chapter from Computer Science paper 2 chapter number 2 instruction set of 8085. In the last video we had started with the arithmetic group and we had completed the three instructions, that is ADDR, ADDM, and the last instruction that we had seen was ADI data. Okay, so now the fourth instruction that we'll see today is ADCR. Okay, this instruction stands, these are all addition instructions. Total we have 6 instructions. Okay, today we'll complete the 3 instructions of this particular arithmetic group of addition. Total we have 20 instructions in this particular group. ADCR, now this instruction stands for add the register to accumulator along with carry. So C, ADC. AD stands for add, C stands for carry, and the register content. So here what happens is register content plus the carry content plus the accumulator content are added and the result is stored in accumulator. Now let us see the format. See here, A plus R plus CY, and the result is stored in accumulator. So hence the arrow is towards A. Addressing mode is register addressing mode. Why? Because there is register in this particular instruction. Group is arithmetic group. Bytes is 1 byte since there is no data, and the flags that are affected are all. Now the comment or the explanation, how will you explain? So what happens? The content of the accumulator is added to the content of the register and the content of the carry flag. The result is always stored in accumulator. All the flags may be affected. Okay, or you can change the sentence from this to some other sentence, but accumulator. So how will you write if you change in this instruction? The content of accumulator is added with the content of register and the carry flag content also. So the result of the addition is always stored in accumulator and all of the flags may get affected. So example, let us see the example. Now let us assume some data for register A. So I have assumed as A as 4CH, then register B. So R I have assumed as register B. You can see, you can take C, D, E. Okay, so A is 4CH, B is 25H. Carry you can assume either 0 or 1, but you need to mention it. Okay, so I have assumed 1. If it is 0, there is no need to show the addition, but actually in the example you will show all of the bits as 0 0 and the result will be the same, but since you will show the 0 0 bits, okay, so I have assumed 0 1 as carry. You can assume 0 0 also, but you need to mention it. So A as 4CH, B is 25H, CY is 01H. Addition of A, B and CY, and the result is 72H. You can try these addition in your book. Okay, so accumulator content you should get 72H. So after execution, now A accumulator is 72H and the flag register also you need to mention. So my sign 0 and carry flag is 0, AC and parity flag is set to 1, and also you need to draw the flag register according to the bits that you have got. So this was ADCR, which stands for add register to the accumulator along with the carry. So A plus R plus CY, that you need to put in your mind. Okay, now the next instruction is related to same as ADCR. So this instruction is ADCM. So it is same. ADCM, this instruction will add the content of memory to the accumulator along with the carry. So same, instead of the register R, you will consider M here. Okay, it is same. So A plus HL. Why HL? Because M is nothing but my HL register pair. So A plus HL plus CY, and the result is stored in A. So I arrow towards A. Addressing mode is register indirect addressing mode. Why? Because there is M. So indirect addressing mode. Arithmetic group, bytes will be 1 byte. There is no content, that is data, in this particular instruction, so hence 1 byte. Flags that will be affected are all. Now the comment, that is the explanation. The content of the memory location whose address is stored in HL register pair is added to the content of accumulator and the content of the carry flag. Correct. So the result is always stored in accumulator and all of the flags may be affected. So the explanation, when you note it down so many times, that you will be getting it that the explanation is same for the next every instruction. Okay, only the thing is you need to learn the format, okay, very well, and the explanation you can write on your own. So the example, let us see the example. Accumulator content that I have assumed is 2BH. Now example also you can take on your own, you can take any data. Okay, so accumulator is 2BH. HL pair you need to mention the 16-bit data, which I have assumed as C050H, and then I have assumed as 8-bit data. Why? Because I need to add with accumulator. So hence C050H is equal to 58H. Then carry, here I have assumed 00. Okay, but since it is 00, you need to mention in the addition the result. Okay, see, in the example that I have shown is CY00, since I have added it. Okay, so instruction is ADCM. So addition is A22BH. You need to write in binary number, then A content, B content, and CY. All the three content will be added, and the result that you will get of the addition is 83H. So after executing this instruction, accumulator from 2BH got changed to 83H. Now my accumulator answer is 83H. Okay, so the flags that you will get is sign flag and auxiliary carry flag as 1, and all the other flags as 0. Okay, then the flag bits you will draw according to the flag register answer that you got. Okay, so this was my ADCM instruction. So ADCR and ADCM both are same. Only in ADCR you will write a register, and in ADCM you will mention the HL pair. M is nothing but the HL pair, but both the addressing mode are different. Since it contained R, so add register addressing mode. Here it is M, so hence register indirect addressing mode. Okay, now the next instruction in this particular group is 6th one, which is ACI data. Now this is the last addition instruction in this particular group. After this instruction will be starting with subtraction instruction. Same, will be having 6 instructions for subtraction also. Okay, so that we'll see in the next video. So today we'll see in this video, this is the last instruction. So 6th is ACI data, which stands for add immediate. I, which always stands for immediate. So add immediate data along with the to the accumulator along with the carry flag. So ACI, I for immediate data, C for carry flag data is already present in the instruction. So add immediate data to accumulator, or add immediate to accumulator with carry. If you mention immediate data also, they will not cut your marks. So format is A plus data plus CY and the arrow towards A. The addition of all these three things will be stored in accumulator, so hence arrow towards A. Then the group is arithmetic group. Addressing mode is immediate addressing mode. Why? Because there is I, which is mentioned in the instruction. Bytes are 2 bytes. Why? Because since there is an 8-bit data, so hence the bytes got increased from 1 to 2. 1 byte for the operand, that is data, 8-bit data, and 1 byte for the opcode always. Flags that are affected are all. So how will you explain this particular instruction? The 8-bit immediate data specified in the 2nd byte instruction is added to the content of the accumulator and the content of the carry flag. The result is always stored in accumulator. All the flags may be affected, or you can change the explanation and you can write as, in this instruction, the content of accumulator are added to the content of 8-bit data, which is mentioned in the instruction, along with the carry flag, and the result of this addition is always stored in accumulator. And the carry, all the flag may get affected. So see, your example that I have taken is, let A as 8AH, carry flag I have assumed as 01. Okay, now the data you need to mention in the instruction only. So before execution, you do not need to mention the data. Okay, so A you will assume as any number that is 8-bit. 8AH I have assumed. Carry flag you need to assume either 0 or 1. I have assumed 1 here. Instruction is ACI, and the data that I have assumed is 28H. You can assume any data. So ACI 28H. Now what happens here? The data, that is 28H, plus the accumulator, that is 8AH, plus the carry flag, that is 01H. All these three things should be added, and the result of addition will be stored in accumulator. So you will write, after executing this instruction, that is ACI 28H, the accumulator result is B2H. Now see, the addition result that I have got is B2H. So you need to know the binary addition very well. Okay, so the 8AH in binary is 1000 and A is 1010, then 28H 2 is 0010, 8 is 1000, 0. By mistake I have taken carry flag as 00 here. Okay, you will write 1. If you write 1, you will get B3H. Okay, try it by yourself. I have taken, by mistake I have taken in the addition carry as 00. Okay, if you take 1, you will get B3H. So accumulator, after execution, the result will be B3H. Okay, and what changes that you will get in flag register is, so flag register P will be 1. So the flag is according to B3H answer. Okay, parity flag is 1. Why? Because, no, 1 minute. B2H, that is total number of answer that you got is 4 ones, which is parity is even. So according to B2H only the answer I have written. So by mistake I have written B2H. Why? Because I have taken my carry flag as 00. If you take 01, you will get your answer as B3H. And if you get B3, the flags also will be changed. Why? Because there will be total 5 ones if you get B3 answer, which is an odd number. So parity flag will be set to 0 instead of 1. Sign flag will be as it is, 0 flag will be 0, auxiliary carry will be 1 as it is, and carry flag also will be 0. Only the parity flag will change. So after execution, B3H you will write if you take carry as 01, and the flag register from the bits you need to mention in the box. Okay, that is dash dash, which means don't care. If you mark it as cross, that is don't care, no, they will not cut your marks if you put a don't care also in the box. Okay, so this was my last instruction in this particular video. In the next video we'll continue with the same group, that is arithmetic group, but with the next instruction, that is the 7th instruction, which will be starting from the subtraction. Okay, so these were all total 6. This video and the previous video, you will be getting all total 6 addition instructions in this particular group. In the next video we'll continue with the same group but with the subtraction instructions. Okay, so thank you students.